All right, it is 10, so we will get started. And before I pop right into the lecture, I just want to make you aware of something I just put up on Blackboard within this last hour. So if we look on the Blackboard page here, you should see that it's not quite here yet. So it'll be on both sections after this lecture. Looks like I copied the wrong folder. But anyways, you will see this folder called Extra Practice Test 1. And what I'm going to try to do throughout this semester is that problems that we have in class, especially these math problems that we're going to start today, I'm going to see if I can't make extra problems for you to try on your own. These problems aren't going to be graded, but they're just a way for you to get extra practice outside of what we do in class, on the homework, and on my practice tests. So just another resource for you to hone your skills. And I do have answer keys with this as well. So you should have the questions and the answers. If you are unsure how I got a particular answer, want more help, I'm always here. So feel free to contact me. So just another resource for you. With that, we will get into the actual lecture today. And the first thing we're going to talk about is the idea of energy. Now, energy is really the ability to do work. And we have two different types of energy that we think about. We have kinetic energy and potential energy. Now, kinetic energy is the energy of of motion rather, and potential energy is the energy of position. Or for us in chemistry, when we think of potential energy, we think of energy in bonds. Depending on how bonds are connected and what elements are connected, molecules have different amounts of potential energy. And we already kind of know this intuitively. Gasoline, for example, when you go to get gas for your car, you put in a molecule that has a lot of energy in it, gasoline. You wouldn't want to put in something that doesn't have much energy, maybe like grass, right? You put grass in your gas tank. That's not going to be nearly as efficient as putting gasoline in your gas tank. So that's just one idea of potential energy. Here on the right, we have an example where we have a weight at the top of a building. Due to gravity, anything that's high up will have a lot of potential energy, right? Because if you would drop this weight, which is being shown here, all of this energy that is stored up due to height is being transferred to kinetic energy until it finally hits the ground. Now, when we're talking about energy, we always have to think about the law of conservation of energy. That law states energy can't be created or destroyed. You can only change forms of energy or transfer it from one object to another. So all of the energy in the universe is set. It's a set number, and you can't increase it and you can't decrease it. You just can change the shape it's in, the form it's in, and that's being shown in the right of the weight. At the very top, when we have it at the top of the building, it's all in potential energy. That energy is stored. When we drop the weight's now moving and it's transformed into kinetic energy. When it hits the ground, what happens to that energy is that it is transferred into the concrete. The concrete atoms will vibrate very fast when they're hit with that weight. Remember, we said on Friday that solids aren't stationary. The atoms inside of solids are vibrating. So when this weight hits the ground, it causes an increase in vibration. And all of this potential energy that was stored goes into the ground in the form of thermal energy. And thermal energy is really just kinetic energy. Whenever you talk about heat, really, heat is our body, lost the word, but it's how we feel how fast molecules are moving. The faster a molecule is moving, the hotter it feels to us. The slower a molecule is moving, the colder it feels to us. So humans have an inbuilt system to determine kinetic energy, and we can feel that as heat or cold. Now, what we're going to mainly focus on today is measurements. And in science, we use what's called the metric system. Now, Americans, we've been taught a really weird unit of measurement, the empirical unit of measurement, where things really don't make that much sense when you think about it. For example, we measure height in feet. 12 inches equals 1 foot. Okay. Well, we also measure weight in pounds. And the lower unit of a pound is an ounce, where we say 16 ounces equal 1 pound LB. First off, like, why is one unit a division of 12 and then another unit a division of 16? Well, you can even go a little more extreme, right? If we want to continue the feet example, the larger unit of a feet that we use to measure long distances, well, that's 1 mile. And how many feet are a mile? What, 5,280 feet, I believe, is 1 mile. Like, where did that come from? We're going like from 12 to 12 feet, 12 inches and for 1 feet, so 12 to 1, to 5,280 to 1. It's just a bunch of memorization of these different units. Scientists don't like that. We want something a little more precise. So we use what the vast majority of the rest of the world use, called the metric system. And although learning the metric system initially is going to be a little confusing for us, because normally we don't use it in our day-to-day lives, once you get it down, though, it's so much easier than the regular system of measurements, because you learn it once, you can know any type of measurement you want. You can talk about weight, distances, depth, amounts, anything is all the same in the metric system, right? And that example here is like when we talk about centimeters to meters, there's 100 centimeters in 1 meter. There's 1,000 meters in 1 kilometer. There's 1,000 grams in 1 kilogram. The metric system uses bases of 10. Everything is always a unit of 10 in the metric system, which makes it easier to remember, in my opinion. And here is the metric system, some of it, all the way to exa. And I know the bottom's cut off for you, but the bottom is atto. We're going to use this a ton in this class. We're going to use this a ton in Gen Chem 2. Basically, any science class that you go in, physics, biology, when you do your calculations, it's going to use the metric system. So what I expect from you by test 1, and more or less throughout this whole course, is we're going to know how to convert. I drew my box a little short there. We're going to know how to interconvert between all these units by memory. That being said, this table, we're going to learn how to use this table. You will not have this table on a test. We need to learn how to memorize and incorporate these into our everyday work, everyday knowledge, because it's not really useful for us if every time we want to do conversion, we have to go to Google and do it. It's a lot better if we can just go right in our head and say, oh, 1 meter is 100 centimeters. That's that. Type into Google. If I have 1 meter, how many centimeters that is. So that's what we're mainly going to work on today, is how to convert between the different units of the metric system. So I have some questions here that I completely forgot about. We'll go on the questions on the next page right here. So we're going to spend some time doing these conversions. But before we do that, I'm going to show you how to do it and what this table on the right is actually saying. So I will do A for us. But first, before we do that, let's read what this table means. All right. When it comes to the metric system, let's say we are measuring length, and the SI, or the metrics unit of length, is the meter. That's how we measure length. Well, the metric system is set up in such a way, depending on what prefix you put in front of your unit, in this case, length, or it could be weight, right? Could be weight. Weight is the gram. It changes how much of that you have. What I mean by that is, if I say I have 1 kilometer, 1 kilometer, that is 1,000 meters. Or 1 kilogram is 1,000 grams. 1 centimeter is 0.001 or 0.01 meters. 1 millimeter is 0.001 meter. So you can see, by putting the prefix in front of our unit, we're changing the amount of that unit. And how much we change in all those prefixes, that's what's being shown in this table. And the way to read this table is, it's saying, for example, kilo, and the multiplier is 1,000. That is saying 1 meter equals, or sorry, I had that backwards. 1 kilometer equals 1,000 meters. Here, 1 decimeter equals 0.01 meters. 1 centimeter equals 0.01 meters. 1 megameter equals 1 million meters. That's how we use the multiplier. You can also go backwards, right? 1,000 meters in 1 kilometer, 0.1 meters in 1 decimeter. Here on the right is our scientific notation version of that, right? So 1 kilometer equals 10 to the power of 3 meters. And if you remember, 10 to the power of 3, that equals 1,000. 10 to the power of 6, that equals 1,000,000. That number up here, 6, 9, 12, that is just telling you how many zeros come after the 1. That's all scientific notation is. It's not something to be intimidated about. It's just, if it's a positive number, how many zeros come after my number? If it's a negative number, right, it's the opposite. You're going backwards. And it's, unfortunately, it's not as easy as for -2, how many zeros are between my decimal and my 1. Because you can see 10 to the power of -1 is 0.1. 10 to the -2 is 0.01. And really, the way I've always remembered that is, let's take times 10 to the -1 for an example. I have 1. And if I want to make it to the -1, what you do is you put the decimal after the 1. And for the minus, you move it 1 place to the left because it's -1. That equals 0.1. If it's -2, you can do the same thing. You do the 1, 1, 2. You make 2 little marks. And every time you have this little divot, you put a 0. So that is equal to times 10 to the -2 times 10 to the -3, 1, 2, 3 times 10 to the -3. So that's how we can handle scientific notation. That's how we can use this chart. Before I move on to actually solving a problem here, any questions about the scientific notation, how to use this chart, or what I expect people to know by test time about the metric system? All right. Well, if there are no questions, everybody doesn't have to say no, sir. By the way, if you don't have any questions, you don't have to actually say no in chat. I usually take silence as a no. All right, so let me clear this. Do we only need to memorize giga to micro? All the others we don't need. For this class, yeah, we're just going to go between giga and micro. For moving on, if you go further in science, I would suggest you know nano as well and tetra. But for us, giga through micro will do it. All right, so let's do it. And what I'm going to show you is a tool I'm going to use about 1,000 times before the end of this course. And it is the train track method for conversions. It's the way I do conversions. And if you have another way you were taught on how to convert between units and you feel comfortable with that method, feel free to use it. I'm not forcing you to do conversions my way as long as you get the right answer. But I will show you how I was taught, and to this day, how I still do conversions using what I call the train tracks. Okay, so I want to convert between 515 kilometers to decameters. So the way I'm going to start is I'm just going to write my unit to begin with. And once you write your unit that you start with, you more or less make a cross. Okay, so that's the first part. Wrote my unit and I wrote a cross. So let's look at the logic of this. The way I'm going to do this conversion is that I'm going to convert between kilometers to meters to decameters. Because if I do that, I can use this chart perfectly. Because remember what this chart says. This chart says 1 kilometer equals 1,000 meters. And 1 decameter equals 0.1 meters. So there's my path. I go from kilometers to meters, then meters to decameters. If you are comfortable enough from converting kilometers right to decameters, by all means do that. But I'm going to do this two-part conversion. And so the first thing I need to do is convert between kilometers and meters. So based on my chart, I say 1 kilometer equals 1,000 meters. All right, so let's pause and just look at, why did I just write kilometers on the bottom and meters at the top of my train track method? Right. The way the train track works is that if you have a unit on the top of your tracks and the same unit on the bottom of your tracks, these units cancel out. So if I have kilometers at the top and kilometers at the bottom, those units cancel out. and the units I'm left with are now meters. So when I do my calculation, up to this point on the train tracks, the unit that I am in are meters. So I'm in meters right now. But I don't want to be in meters. I want to be in decameters. So I need to make another track. And I'm going to convert between meters to decameters. Again, the logic is I have meters at the top. I don't want to be in meters, so I need to cancel meters out. The way to do that in this method is you put the unit of meters on the bottom. They cancel out. And I'm left with decameters at the top. And now I just need my conversion factor from the chart. From my chart, there's 0.1 meters for every 1 decameter. So if we look on our train tracks, when I do my calculation, my final answer will be in decameters, which is what I want. That's what the conversion is. And the way to do this with the train track method set up, you take the top numbers and you multiply them together. So in your calculator, you're going to do 515 times 1,000 times 1. Now I'd hit enter at that point. Then whatever number you get at the top, you need to divide it by your numbers at the bottom. So you take your number you got from multiplying the top, divided by the bottom number, which is 1 times 0.1, or just 0.1. And the answer you should get, if I put it into my calculator, right, should be 5,150,000 decameters. And that's the answer for the A. And using the train track method and using this chart, you can do any metric system conversion I can ever give you, or you'll ever like encounter in your careers or in life. So with that example out there, I'm going to give everybody some time here to do B, C, D, E, and F. See if you can follow my logic. See if you can follow the chart and do those conversions. If you have questions or if you have answers and you want to check them with me, please let me know. Otherwise, I'm going to give you some time here to try and do these conversions. Again, if you have questions or you have answers you want to check with me, feel free to just send me a message and I'll be happy to help out.